Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do, but it's about making sense of problems, where we notice patterns and we reason using mathematical relationships. Y'all, we can mentor students to think and reason like mathematicians do. Not only are algorithms really not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. Really not particularly helpful? Particularly not really helpful?
I didn't laugh until just now.
There was a few more, too many Lee words in that sentence. Oh, well.
Oh my goodness. How are you doing?
I'm doing fantastic. How are you?
I'm good. Hey, so I'm loving the reviews, which is super, super fun to read. And I wanted to share one with you that we got about a month ago. And this one is from Gypsy Tango. And Gypsy Tango, I don't know if it's a he or she, but they said, I'm a parent helping my child learn math, which automatically I love. I'm learning a lot from the techniques and perspectives discussed. Pam and Kim are a great team and funny too. Thank you for helping me become a PT math teacher for my son. I'm assuming parent math teacher for my son. Great podcast.
Woo.
So I love that because we are our kids' first teachers, right? And we love parents who get to listen in. So thank you, Gypsy Tango, for listening and for diving in to do math with your son. I bet you're getting a great experience.
Fantastic.
Speaking of sons, one of my favorite things to do is talk math with my kids. I'm super fascinated by how they think and what they're learning about. And so
and before you go on, we probably should shout out, because you just quoted Christopher Danielson, Talk Math with Your Kids.
Like I didn't know.
Oh,
good.
Okay.
Thank you for stopping me. Good.
Yeah, he has a sticker and everything. What is it? Talk Math with Your
Kids.
Yes.
I do know what you're talking about. Yep.
Yeah. And he's fantastic and fun. And hey, another shout out to Christopher Danielson. I went to a thing he did. Where was that? Oh yeah, it was New York City. I was in New York City and I decided to go to the Museum of Math or Math Museum, MoMath, whatever MoMath stands for. And randomly he was doing a presentation. He's from Minnesota. I'm from Texas, or at least living in Texas.
Yeah.
And the two of us met up in New York City while he was doing this presentation at MoMath. And the reason I have to say it is he was doing this thing with tiling shapes. And I remember thinking, this is fun, whatever. My son showed me the other day this whole new proof that just came out with this Einstein shape about tiling the plane with this shape. And anyway, I was just, Christopher Danielson, I had to smile. I had to smile big because I was like, he is onto something with this tiling thing. Anyway, so there you go. Way to go.
Super cool.
It was really fun. Well, speaking of talking math with your kids, it was me and my son. Yeah.
That's super cool.
All right.
Well, and I know that when your kids came home and you said, how'd school go? You really meant how did math go? And I kind of feel the same way. So I try to ask about other subjects, but they're probably knowing that I'm just waiting to hear about what they're doing in math. So anyway, I'm super fascinated. And, this past summer, my kids had some downtime. They're not quite old enough to get a job, but they have too much time on their hands. So I, have a younger son who, sometimes the short-term memory is not amazing. And so I wanted to keep things fresh with him. Right. And so we talk math all the time, but this past summer I said, hey, we're going to spend some time this summer doing some math. And so I did some problem strings with them, and we just talk about math in general. But I also decided that for the first time ever, I was going to sign up for an online site. And it really didn't matter which one it was, but I wanted to just have a bank of problems that we could bounce around and we could think of different things, because I'm working and
You really just didn't want to come up with your own problems. You're like,
exactly. That's
somebody just
exactly right.
generate some
Yep.
problems for me. So you could have
Yes.
used Chat GPT, but you
Yep.
decided to whatever.
Yeah.
Yep.
Yeah.
Yep.
Yeah.
Okay.
And so, I sat next to him, which I think is the crucial part of any of these online programs is that we send kids away and like go do some stuff. But I think what the most important thing you can do in that moment is sit and share and listen. And so that's what we did.
Hey, I'm going to pause you for just a second.
Yeah.
Because I think somebody might hear that the most important thing you did was sit next to your kid to like um, enforce that he's doing it. Like
Oh,
to
thank you.
that's
No,
not
no,
what
no,
you
no,
mean,
no,
right?
no, no.
It's not
I
about like
mean,
making sure it happens. Dude, you better get this.
oh, no,
That's
no,
not what
no.
you meant.
No, I meant I want to have a problem come up and say, how are you thinking about it? And listen to what he's saying and how he wants to approach the problem. And it just provides an opportunity where I don't have to come up with every problem for us to have a rich conversation.
Mm-hmm, mm-hmm.
So he was working on some problems one day and I was sitting next to him and a particular problem came up. And so I'm going to give the problem because I want our listeners to think about the problem first before we talk about it. And the
Okay.
problem was 8,099 and 73 hundredths divided by 27.
Okay, so I'm writing that down, and I just
Okay.
wrote down 8099.73
Divided by 27.
divided by 27. So I
Yeah.
I understood 8,099 and 73 hundredths correctly.
Mm-hmm.
Okay.
Yep.
Okay. Good. Good.
So if you're listening, you should pause the podcast and spend some time thinking about that. But we're just going to dive in.
That's an ugly looking
It
problem.
is. It is pretty ugly.
Yeah.
And so
Wow.
my son Cooper saw the problem and he literally said, no way. Mm-mm. And he kind of shoved back. And I said, Coop, what do we do if a problem feels maybe a little bit hard? And it's a division problem, right? And he was like, oh, he's like, I can do a ratio table. And I said, go, let me see what you've got. And so I'm going to tell you what Cooper did.
Okay.
And he wrote down in a ratio table 1 to 27. He was thinking about how many 27s were in 8,099 and 73 hundredths. So he
Nice
wrote 1 to
quotative approach.
Yep.
Yep.
So here, 1 to 27.
Mm-hmm.
And then he wrote 100, which was 2,700. I'm going to grab a piece of paper. 100 to 2,700.
Mm-hmm.
And then he wrote 200, which was 5,400.
Okay.
And then he went 300, which was 8,100.
Mm-hmm.
And so he had 300 and 8,100. And then I asked him, where are we? How far away are we from where you're headed? Because he knew he was heading to 8,099 and 73 hundredths. So he got the biggest grin on his face. And I was like, what are you smiling about? And he said, oh, we're only 27 hundredths away. And so he looked at the 1 to 27.
That's so nice, right?
No, it's a pretty yucky looking problem, right?
Well, yeah. So 8,099 and some stuff is just a little bit away from 8,100. Yeah, that's really nice. Uh-huh.
Yeah. So at this point, he looked at the 1 to 27 and he grinned really big. And he said, I know it's going to be 299. And called it, so 299, let me see what he wrote. He wrote, I don't have paper, 299, which would put him at 8,073. Is that right?
Yes.
And then we had a little bit of a place value conversation because he knew he was supposed to do something with that 27 or that 27 hundredths. And so he did tinker around a little bit at that point about, is it 1 away? Is it a 10th away? Is it a 100th away? But I was so pleased with him that he had a model, a tool that he could think with. And he was like, I'm going to do this. It's going to be great. And then he was using some relationships that he knew.
Nice.
And then we just tinkered around a little bit with place value. And he ended up with the correct answer.
And
Yeah.
so, like even when he got to that 300, the ratio of 300 to 8,100,
Uh-huh.
and then could figure it's going to be a little less than that, the answer is already between 299 and 300.
Yeah.
Right? Yeah, that was nice.
Yeah.
Cool.
So then, if I remember correctly, I called you and I was like, "Hey, Pam, what do you think of this problem?" Because that's what we
hmm
do, right?
hmm Yep, yep.
Do you remember what you did?
I think so, because I think I made a place value mistake off the bat. And so today, when I knew we were going to record this, I went ahead and solved it fresh.
Okay. Well,
Um,
tell me what you do today.
I don't know that I remember exactly how I did the place value wrong last time.
Okay.
Um, all right. So I also made a ratio table, and I was thinking about the ratio of 1 to 27. And I looked at that 8,099, and I was like, that's almost 8,100. It's so close to 8,100.
Mhm.
And I know there's a relationship between 27 and 81. So that 8,100 felt like 8,100.
Mhm.
And so I think it has to do with exponents, really. I think I've done 3 to the 4th, which so 3 squared is 9, 3 cubed is 9 times 3, which is 27. So 3 to the 4th is 27 times 3, which is 81.
Mhm.
And there's that nice connection where that 3 to the 4th is the same thing as 3 squared times 3 squared, or 9 times 9, which is 81. Anyway, there's just all these connections now that I kind of have in my head that I said I could get from 27 to 81. And so on my ratio table, I've got 1 to 27, 3 to 81, and then 30 to 810, and then 300 to 800 to 8,100.
Yeah.
So Cooper did kind of a little bit of a different relationship to get up to 8,100.
Mhm. Mhm.
I went to 3 to 30 to 300. And then I had to think, how is 8,099.73 related to 8,100? And I literally then wrote down 0.27 because
Mhm.
I have you need in my head. I said,
Mhm.
if I have 0.73, what do I need to make 1? I need 0.27. And then I had to ask myself place value. Like Cooper and I
Yeah.
we were both messing with place value. And so on my ratio table, I've got that 1 to 27, and then, all the other stuff I said, and then 0.27. So I'm asking myself, how do I get from 27 to 0.27? And Kim, you know what I did? I feel like I did what my mom does. Next to that, I said, I'm going to go from 27 to 2.7. So 27 to 2.7 is a
Mhm.
tenth. So I divided both by 10. So 1/10 is to 2.7, but I know I need to get to 0.27 or 27 hundredths. So then I divided by 10 again. And so now 0.27 is in the same ratio as 0.01 or 100th.
Yeah. Yeah.
Okay, so now I know that I just need to subtract that 0.27, the 27 hundredths, from the 8,100. And so I'm going to subtract 100th or zero point zero 0.01 from the 300, and 300 subtract 0.01 is 299.99, or 299.99 hundredths.
Yep. What I love is that you both used a ratio table to keep track of your thinking, right?
Keep
You
track of
used
what
it as a
we know. Uh-huh.
yeah.
Yeah.
And what I wish that I had done when I was working with Cooper is once he called it 299 and then he was like, "Wait, no, that's not right." Um, he was talking aloud at that point, and I didn't say, "Hey, how about you put those on a ratio table?" Because I think that had I encouraged him to do that, I think he would have done the same thing you did, scale down by 10, and he would have been able to hang on to it a little bit. And so as I'm hearing you talk about that, I'm kicking myself a little bit because in that moment we just started talking, talking, talking. And I think that's a tip for all of us as we're working with our students, both as teachers and parents, that sometimes kids want to hold things in their head a little bit, maybe because they think it's desirable. I don't know.
Or we're all a
Maybe,
little lazy,
yeah, I was gonna say maybe
maybe.
in
Yeah.
some of my kids' case, a little bit lazy.
I think we
Yeah.
all are a little lazy. Sure, sure. I mean, I'm messing with a kid. Can I say that? I was doing math.
Mathematically.
I was doing math with a kid at church on Sunday,
Yeah.
and asked a question. And I think it was just I haven't done any math with this kid for a while, and I was like, "You're older. Let me think." And he's not very old. I think this kid's probably 8, 9, 9, 10, 9 or 10. And so I said something like, "What's 39 plus 10?" And she said 49. And I said, "What's 39 plus 9?" And she had to think. And she said 38. And I said, what's 47 plus 10? She said 57. And I said, what's 57 plus 9? And at that moment, I could see her trying to like hang on to numbers. And I said to myself, oh, this would be so much better if I could just draw a number line and just write
Right.
that 48 plus 10. And I wouldn't have to write anything else, or maybe
Yep.
just write the 58 down, and then, well,
Yep.
how about plus 9? And she'd be like, oh, it's one less than that. And then she wouldn't have to be, when she says it's one less than that, what she doesn't have to do is then say, what was the problem before that? She could
Right.
just see it, right? It's not about how much you can hold in your head. It's about what are the relationships you're using. It's totally cool to keep track. Yeah.
Yeah.
Nice.
Yeah. So Cooper ended up with the wrong answer at first. I mean, it was not correct. But what I found in that moment really intriguing, interesting,
Yeah.
exciting was that he saw that division problem, and when I just was there to say you have a way in, then he was able to relate multiplication and division.
Mm.
We saw him scaling proportionally.
Mm-hmm.
And his answer was reasonable, even though it was incorrect in the beginning. It was reasonable rather than way off, which
Totally.
if you're having kids do the long division algorithm, this is awful. This particular problem would be awful.
Kim, I have to tell you, just as you were saying that, I was writing down the long division algorithm.
Oh, it's
Like just the housetop. I didn't start doing it
yeah,
or anything because I was curious. I was like, I wonder how bad this would be with the algorithm. And
it's
instantly, I'm like, 27 goes into 8.
yeah,
27 goes into 80. I'm sure it does.
yeah, yeah, yeah,
And
yeah.
then
It's
after that, you're gonna have all these nines, right? Just over and over. Oh, that's
yeah,
terrible in the long division
yep,
algorithm.
yep.
Yeah, nice.
Anyway, so I have one other story if we have time for it.
Yeah, yeah.
So I was talking about Cooper in division, and we had some division problems in Math Strat Chat, not too terribly long ago.
Math
And
strat
I sometimes it comes out in the evening, so sometimes I just kind of like take my phone and shove it in my kids' faces because they're excited to see it, but they don't know when it comes out. They pay no attention. And so the Math Strat Chat problem was 1,176 divided by 48. And I don't know if any of the listeners saw that problem when it came out, but 1,176 divided by 48.
Mm-hmm.
And I walked up to Luke and I kind of shoved it at him. And his response was, Mom, I'm tired. And I literally looked at him and said, Are you serious? How close is it? And he was like, Oh, 1,200. So 25 and half, so 24 and a half. And I was like, wait, what? He was like, you told me to think about it. And so he literally, as soon as somebody said, what's close, which is the same question that I had asked Cooper, he needed just a little bit of a nudge to basically say, like, what do you know? What's reasonable? And he was able to think about 1,200 divided by 48, which he knew was 25 because 2,400 divided by 48 would be 50. So 1,200 divided by 48 would be 25.
Okay,
But it was
cool,
a
cool.
little bit too much.
The 1,200 is a little bit more than the
More,
1,176. Uh-huh.
It
Uh-huh.
was 24 too much. And so 24 divided by 48 was just a half. So in that moment, I was like, noted. Sometimes even older students look at a division problem and they're like, that's yucky. I don't want to engage maybe.
Mm-hmm.
And so, for my kid, I basically said, Are you serious? I wouldn't recommend that with your students. But if we can give them opportunities to think about problems and nudge them to think about what they know, yeah, that can be super, super useful.
That's so awesome. I do think there are students, know your content, know your kids. When you know your students well, I think there are students who rise to that challenge of, where you can look at them and you go, what you got?
Uh-huh.
Come on, dude.
Yeah.
Like, buck up. Like,
Yep.
bring it on.
Yeah.
I do the same kind of trash talk when I'm playing basketball with kids. Like,
Yep.
You think you can shoot from out there? Do it.
Yep.
Pump that thing. For this problem, come on. What do you got? Like,
Hmm.
bring it. Bring what you've got to this problem, and let's have some fun. That's really cool. I love how you did that. It's so interesting that you're just like, are you serious?
Yep. So we actually then talked and I said, Hey, how about you write a problem string? to help build these relationships. And
Uh,
of course, that's what you do. And so what is a string? I haven't seen it yet. What is a string that you can do to build these relationships with kids?
all right. So, brand off the press. Here we go. Ready? What
Okay.
if I were to say, hey, Kim, I've got a bag of Skittles
Okay.
that have 22 Skittles in it.
Okay.
And so that bag, and I just wrote down because I'm going to keep track too. That bag of Skittles, one bag, 22.
Got it.
What if I had 66 Skittles? How many
Oh.
bags would I have?
I say that that's 3 bags
Okay. Because 3 times
because
22.
if one bag has 22, then I have 3 times as many Skittles, so 3 times as many bags.
Okay, cool. What if I had 660 Skittles?
Mm.
How many bags would we have?
I would have 30 bags because 660 is 10 times as many Skittles than the 66. And so 10 times as many bags than the previous 3 bags.
All right, so 30 bags for 660 Skittles.
Mhm, mhm.
This is a little weird, but what if I only had 6.6 Skittles?
You'd be sad.
Yeah, no, I don't really like Skittles, so I'm okay.
I'd be sad.
You'd be sad.
Okay, so on my ratio table, I am writing divided by 10 from 66 to 6.6. So I'm also writing divided by 10 to get from 3 to point 0.3. 0.3 bags.
So
0.3
0.3
of a bag.
bags of 6.6 Skittles. That's
Yep.
interesting because on my ratio table, I had written down your 30 to 660, but you didn't go from that. You went back up to the
I
66
did.
and divided by 10. I like that. It's a nice move. Nice using what you know. What if
Mhm.
we had 666.6 Skittles? How many bags?
Goodness. Okay. 666. I'm gonna say, 666.
Point 0.6.
Oh, point 0.6. Okay. So I've got 660.
Uh-huh.
I have 660 for the 30 bags. And I've got 6.6 Skittles for the zero point 0.3 bags. So I'm going to put those together and get 33.3 bags.
Cool.
Okay. That's a
What
lot of
if
sixes. Okay.
it's a lot of sixes?
All right.
I'm going to have some more here for a second.
Okay.
What if we only had 66 hundredths of a Skittle?
Good gravy.
I know, sorry. I probably should have done something that was less discreet.
That's okay. I'll just
Something that was more
nibble on one tiny Skittle. Um,
2/3 of a Skittle almost.
it's almost
0.66 of a Skittle. How
horrible.
many
Okay.
bags would you have?
So if zero point 0.3 bags is 6.6 Skittles,
Hmm.
then 3/100ths of a bag is 66 hundredths of a Skittle. So I'm dividing by 10 again.
Cool. So 0.03 bags has 0.66 Skittles.
Okay.
Nice. Next problem. What if I had 660.66? 660 and 66 hundredths?
Okay. I'm going to go
660.66. Uh-huh.
Yeah. I'm
How
going to
many?
go back to the 660 Skittles, which was 30 bags. And I'm going to add the 66 hundredths, which was 3/100ths of a bag.
Hmm?
So that's 30 and 3/100ths bags of Skittles.
So 30.03 bags of Skittles for
Mhm.
660.66
I really hope people
Skittles.
have already solved
Yeah, I
or
hope you're
are
not driving. This is,
pausing.
we should have probably said, don't be driving while you're trying to
Yeah.
picture this. There's way too many sixes and threes, all the
Mhm.
things. Last problem. Last problem.
Okay.
How about 659.34 Skittles?
Okay.
How many bags?
That is really close to 660. It's 66 hundredths away. So I'm going to go with 660 Skittles, which is 30 bags. And I'm going to subtract the 0.66 Skittles, which is 3/100ths of a bag. So I'm calling that 29 bags, full bags, and 97 hundredths of another bag. So 29.97.
Bam. And so you just solved the problem 659.34 divided by 22. So it was a little similar, right? We were like, how can we come up with a problem string that could help kids build relationships so that they could solve a problem like the one we started with. Well, so if the problem was 659.34 divided by 22, bam, we just kind of built some relationships that could help you kind of think through not only that problem, but several problems, right?
Yeah. Well, and I want to point out that, sometimes people will see you do some work on a ratio table where you do several problems to just go in and out of different relationships. And then you get to the last problem and they're like, yeah, you had to do all those problems. And I would argue that you didn't. I just
Mm-mm.
sketched out 1 to 22. And if I knew I was heading for 659 0.34,
Mm-hmm.
then I would have a significantly shorter ratio table that would just
Mm-hmm.
head me towards where I was going. I wouldn't need all those interim pieces, but it's fun to play with the relationships kind of in
Well,
and out of the problems you gave me.
yeah, and the reason for doing a problem string is not so that you could answer the last problem.
Right.
It's so that you build mental relationships in your head so that you can answer problems like all of the problems in the string, including the last problem.
Yeah.
Yeah,
Yeah.
it's not just a series of here are the steps to get to one problem. No, it's like, let's build these relationships. So now you own these kinds of relationships so that when I give you any of the problems in that string or the problem like we started with, then you own those relationships. You can use those to solve future problems. Kim,
Yeah.
I've been thinking a lot about the fact that teachers will say to us, but Pam, like my kids own these relationships, they can solve some problems, but what if we give them this ugly problem? Like the problem you just solved was super, it came out really nice. I'm like, nice? You call that nice? I mean, the answer was 29.97, but it wasn't, I guess it could be uglier. It wasn't repeating. It wasn't non-terminating. Like there were lots of, but this one's not particularly nice. Sure, there are uglier problems. But the bigger point I kind of want to just bring up here is I think there's a culture that I'm going to push back against. And I think there's a culture that says we must teach students the end goal is that students can solve any problem of a type of problem, no matter how gnarly, no matter how ugly, no matter how obscure that you'll never hit in life, whatever. Because what if, we got to teach the kids a way because they might hit this problem on a test in
Yeah.
life or whatever. To which I would say, maybe that was true before technology. Maybe. I'll grant you that if you were going to be an engineer in slide rule times, you probably did need to be able to solve any of the gnarly problems, but not anymore.
Right.
What we need now, and I might even argue what we've really needed in all of history, but what we for sure need now is students who own the major relationships, because that means their brain is thinking in a certain way. Their brain is literally thinking more sophisticatedly about relationships, and we can now build more mathematics on that. They are more confident in the math they do. They're using relationships that bleed into lots of other areas in their lives where they are now thinking and reasoning like a mathematician. And when they then hit a problem that they maybe don't own some obscure relationship to be able to solve that particular problem, no problem. They can throw it in technology because they know what they're doing. They're confident that they're putting the right problem in technology, and the calculator, computer, chat GPT, AI can just throw back that obscure, but we've already gotten close, right? That, like you said earlier, Cooper's answer was reasonable already. That is so much more important. So I want to push back against this idea that we have in our culture that when I teach division, boy, I better make sure kids can answer any division problem. No, not true. We need them to own the major relationships and be thinking about division. That is so much far more important.
Yeah.
Is that a sentence? So much far more
So much
important?
it can be.
Okay. It is today.
It's your podcast. You can say whatever you want to say. So today we represented our thinking on a ratio table. If those are new to you or you want to hear more about ratio tables, we have a series starting at episode 129 that you can tune into. If you're also curious about a podcast that we called If Not the Division Algorithm, Then What? That is episode 98.
Check those out. And y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable. Thank you for listening and making math more figure outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.